Hello guys, welcome back to another video. Today we'll be looking at circle theorems part 1. Rule 1. Rule. The angle in a semicircle is a right angle. When a triangle in a semicircle is formed with one side as the diameter, the point where the other two lines meet at the circumference of the semicircle is a right angle. So on the diagram on the left, we can see that O1, O2 and O3 are all right angles formed from triangles which have the base as the diameter. In this case, the diameter is UV and the center is V. Center is C. In theory, the angle at the center is double the angle at the circumference. So in this case, C equals 2O. So then C is 180 degrees. So now we'll be looking at proof for rule 1. So most circle theorems need a proof. So this one we'll be looking at needs a proof. So we need to prove that A plus B is 90 degrees. So here I've labeled some of the angles. So we can see AB at the top, which form the right angle. So I draw a radius to split the right angle in two. So A is 45 degrees and B is 45 degrees. And we can see all the radii in this diagram. And so once I drew a radius, that means I split the triangle into two smaller triangles. So the first triangle is 2A, and the second triangle is 2B. And so 2A and 2B will have to add up to 180 degrees because angles in a triangle add up to 180 degrees. So then if you want to get A plus B is 90, we just have to divide both sides by 2 to get A plus B equals 90. Now we'll be looking at rule 2. So there are two parts so I put two different rules in one because they're really closely related. So part 1 of the rule is that radius is perpendicular to any tangent to the circle. So the other part of the rule is that, so if we refer to the diagram with the blue circle, so we have to prove that AB is CB. And so to do that, first we have to notice that angle BCX equals angle BAX, which are both 90 degrees. Because the angle between the tangent and the radius is 90 degrees. And also AX and XC are both radii of the circle. So that means length AX is XC. So we can find this out even if we don't know by looking at small arrows, small lines drawn on the radii, which show that means they're the same. And also circle with two identical tangents from point B. So that's what this is with the triangles AXB and CXB. So to actually prove it, we have to draw the line XB to create two triangles XCB and XAB. So these share the length XB. So the triangles XCB and XAB are congruent because of the RHS rule. So which means that the right angle, one side, and the hypotenuse are same in both triangles. We'll be looking at RHS, SAS, SSS, ASS, so which are similarity and congruency of triangles in a different video. So the hypotenuse XB is common to both triangles. Sides XCA and XC and XA are radii, so therefore they're equal. The triangles are right angle as the angle between the tangent and the radius is 90 degrees. So therefore, triangles XAB and XCB are congruent. So if they're congruent, that means that CB and AB are equal. Okay, so question 1, 2. Points A, B, and C are all on the circumference of the circle. Line AB is a straight line going to the center, O. Calculate angle X. So that's question 1. And here's question 2. So if we go back to question 2. BDE are points on a circle center O. ACB is a tangent to the circle, and BE is the diameter. So angle DBE is 35 degrees. Find the size of angle A, B, and D. So remember, for these two questions, these are based on the rules that we've learned about today. So answers. Question 1. Angle ACB is 90 degrees because the angle in a semicircle is a right angle. So X is 58 degrees because angles in a triangle add up to 180 degrees. And question 2. So when a tangent meets the radius, it's 90 degrees. So ABD is 90 degrees. Also remember, the proof that I showed in rule 2 is for the second part of rule 2, which I'll be talking about in another video. Thank you for watching. I hope you liked my video. So please subscribe and like to my channel. Please subscribe to my channel and like my video.